For the next talk, please welcome Ronnie, who will talk about how you can attack Active Directory from non-Windows machines.
Cool, thank you. Can you all hear me okay? All right, thanks for coming. I'm super excited to be here and give this talk. This is Fun with LDAP and Kerberos, or Attacking Active Directory from Non-Windows Machines. Real quick, who am I? My name's Ronnie. I'm from Chicago. I have ADD when it comes to security. I seem to just jump around. I started in NetSec, I did AppSec, I'm in ProdSec and DevSecOps. But AD security was sort of my first passion, and it's still what I really love researching and working and doing some tool development in. Worked at various companies. I just started at Motorola Solutions. I'm doing AppSec over there. I'm RopNop on Twitter, and I have a GitHub, and I blog occasionally. I'm going to be referencing several tools and repositories. You can find them on my GitHub, and I'll tweet out the slides after this. So first, a little bit of background about why this talk. This was actually, a lot of this material was born as a workshop I gave at a Chicago conference last year called ThoughtCon, and the workshop was targeted towards like people who wanted to get into AD pen testing. So I covered a lot of the basics and kind of the foundational knowledge for AD security. So I'm going into this talk and I'm assuming no pre-knowledge. So if you're just getting started in AD security or you're just interested in pen testing, this is a great talk. For those of you that are pen testers or have a solid knowledge of AD security, then my hope is that you might be able to take a few things away from this and learn a few new tips or techniques. But really it comes down to automated tools are awesome, and when I started pen testing I was using a lot of them. But I find that doing things manually or looking under the hood makes it a lot more interesting and really lets me absorb that knowledge. And to be an effective Windows pen tester or researcher, I really strongly believe you have to understand the underlying technologies that are in play and don't just rely on the tools that kind of abstract that away. And I think that manually doing things really lets you become more creative as a pen tester or a researcher. So like I said, key takeaways for you guys from this talk is if you're new, I want you to have a better understanding of the underlying technologies and protocols. If you are a pen tester or experienced, maybe some more tricks for your pen tester bag. The slides are dense. I'm going to have a lot of screenshots and commands in there, and I'm going to, kind of be clicking through them quickly. But I did that deliberately because I like slides that can be taken as kind of a standalone cheat sheet. So you can always reference these slides if you're on an assessment or you're just playing around in your lab. And really what it comes down to is I put this talk together as the talk that I would have loved to have seen a couple years ago. When I was getting started in AD security, there was concepts that weren't quite clear to me. I wanted to see things in action. So this talk is the talk that I would like to see, and hopefully some of you guys enjoy it too. Quick agenda. I'm going to do some level setting and an intro and background to Active Directory. Then we're going to jump right into just fun with LDAP, an overview of LDAP and some demos for doing LDAP queries. And then fun with Kerberos and some demos of different Kerberos tools and techniques. And then hopefully time permitting, I've kind of been buttoned up right against an hour, but we have Q&A, or if not, coffee break after this, I'll be around. So you guys are in the AD security track, so I'm assuming you have some idea of what Active Directory is, but I don't want to assume anything, so I just kind of want to level set, because Active Directory gets thrown around a lot, I just want to have a quick overview of like what is Active Directory when I'm referring to it. So AD is Microsoft's proprietary directory service for use in Windows domain networks. And when I am referring to AD, I'm actually referring to ADDS, or Active Directory Domain Services. And AD is kind of a suite of tools and protocols and technologies to allow an administrator to manage objects on their network. And in AD, everything is an object. You've got users, groups, computers, policies, printers, subnets, DHCP leases, everything's an object, and AD gives you the tools you need to kind of remotely manage them. And it relies on various different protocols and technologies to provide location lookup, authentication and authorization, and remote management. In any single Active Directory deployment, though, it really comes down to what I consider like the three big protocols. You're always going to find these in play on any sort of Active Directory domain, and I think it's kind of what Microsoft built a lot of Active Directory up on. And those three are DNS, LDAP, and Kerberos. So DNS is required in Active Directory for resource lookups. It's how resources find each other. And a quick example is like DNS is so important because if you want to join a computer or you want to log into a domain, it uses DNS to identify where the domain controller is to begin with. LDAP is the directory access protocol, and you kind of think of it as like how to store and access all those objects that make up an Active Directory domain. And LDAP is a standard that predates Active Directory. It's an open RFC. And so Microsoft adapted LDAP and built a lot on top of it and added some extensions and new attributes, but LDAP is really still the core underlying directory access protocol in AD. And then lastly, Kerberos, the big one. Kerberos and Active Directory provides authentication and a single sign-on experience. And similar to LDAP, Kerberos way predates Active Directory as well. It's an open RFC. But Microsoft took that Kerberos protocol or Kerberos RFC and kind of bastardized it and added a bunch of things on top of it to make it work. But it's still Kerberos at its core. And there's lots of other protocols and technology that I'm not really going to touch on here, but you've probably seen NetBIOS, MS-RPC, NTLM authentication. Really, all of this stuff is just, it's a hodgepodge that makes up Active Directory. But these are the three big ones I'll be focusing on because they're backwards compatible and open protocols. So DNS, LDAP, Kerberos, they're open protocols, like I said, and there's other clients you can use to communicate with them. So what it comes down to is really in the crux of this talk is you don't have to rely on Windows to talk to Active Directory over the network. These protocols are open, and as long as you have network access, you can use any clients that you want to talk to them. So from here on out, I'm not going to use Windows at all. There's no PowerShell in this talk. I'm sorry if you were expecting that. But I'm only using pretty much Python and Linux. And the idea is as a pen tester, you should be able to pen test from wherever you land. If you don't have access or a foothold to a Windows machine, if you get a web server or a container or a smart fish tank, you should be able to still do some Windows pen testing if you're in an Active Directory domain. So these are some of the tools you can use to talk to these protocols here. And I'm going to kind of jump into some examples here. DNS is in play, and ADDS heavily relies on it. And if you have DIG or any just standard DNS tool, you can actually perform some domain reconnaissance if you land in a network. DNS especially relies on serve records to identify where the important services are, such as LDAP, Kerberos, and Global Catalog, which is kind of LDAP for the forest. And you can just use DIG, for example, to do serve record enumeration and find out where the Global Catalog or LDAP servers are, where the Kerberos servers are, and start mapping out your domain. You can also use an Nmap script, but this is just showing in my test domain here, through DNS serve enumeration, I can identify right away that I have one domain controller, and it's called pdco1.lab.ropnop.com, because that's running LDAP, Kerberos, GC, all of that good stuff. Now, when you identify an LDAP server, and I'm going to be talking a lot about LDAP in a couple slides, but most LDAP reconnaissance requires an authenticated bind. However, if you do an unauthenticated bind to an Active Directory LDAP server, you can still pull some valuable metadata. Sorry, I'm blocking the screen. You can still pull some valuable metadata from the LDAP server itself. And you can use any LDAP client, like Idapsearch, for example, to pull that data out. So this is just an unauthenticated LDAP bind. And over here on the left is sort of a snipped output of all the attributes that come back about that LDAP server. I bolded some of the more useful ones, but I think the most useful ones are these three down here. They're numeric values that correspond to what the functionality level is of the domain, the forest, or the domain controller. And if you just look up those values in the table over here, we can see just through an unauthenticated LDAP lookup that we're dealing with a Windows 2012 R2 functionality level. Now, MS-RPC is definitely big in play in Active Directory, and I'm going to just gloss over it real quickly here. But MS-RPC is Microsoft's twist on DCE-RPC. It's actually made up of several different protocols, but the idea is that every computer within an Active Directory domain can communicate to each other and do remote procedure calls. And the most common way that MS-RPC occurs is RPC over SMB. So it's using named pipes over SMB. So if you've ever had any confusion about like why SMB, which is for file sharing, you can get code execution through, it's because you're actually mounting a named pipe and doing an RPC call through the file share functionality of SMB. So all net commands are doing MS-RPC under the hood. So if you've ever run like a net user command, /domain will actually communicate to the domain controller and do a bunch of MS-RPC calls. And it establishes an SMB connection, it drops into SAMR, it does a ton of lookups at the domain, and then it displays that information back to us. But under the hood, Microsoft does all this automatically, and these are the types of protocols that are in play for RPC. Now, although it's proprietary, there are other implementations of MS-RPC, and you don't actually need Windows to talk MS-RPC. And the two big ones are the Samba project, which has SMB client and RPC client, as well as a port of the net command, or my favorite, which is Impacket. Quick show of hands, who's used and familiar with Impacket before? Cool, so about, yeah, maybe 3/4 of the room. Impacket's awesome, I can't say enough of it. It is a full Python implementation of the MS-RPC stack, or almost full. So Impacket is like the Swiss Army knife for Windows network pen testing. It is my go-to toolkit. If I'm ever doing a Windows pen test, I absolutely have to have it. But I will admit that dependencies can be a little difficult. Impacket requires Python 2. There's some crypto modules that have to be installed. So I really wanted Impacket to be able to work wherever I land. Anywhere I can get a foothold, I want to run an Impacket script. So I released a project. It's on GitHub. I set up a CI/CD pipeline to continually build static binaries from all the Impacket example scripts. So these are standalone binaries that don't have any other dependencies, and you can download them and run them wherever you might land. So under the hood, I'm doing PyInstaller, and I'm compiling them for Linux against the oldest version of glibc I could find. I'm doing wine to compile Windows exes, and then I'm also compiling them against a different libc implementation that's really popular in containers. So if you ever land in a container like Alpine Linux, you can still run these Impacket binaries. And here's a quick example of what that looks like here. I'm on a container, Python's not installed. I want to run an Impacket script though, so I just downloaded directly from my GitHub releases page, a chmod plus exit, and then I have a standalone binary with no other dependencies, and I can just run wimi-exec against a Windows machine that this container has network access to and execute some commands that way. So that works. All right, enough about MS-RPC. It's hard, it's gross. I like LDAP more. So like I said, Active Directory uses LDAP. It's the underlying directory access protocol. And really every single object, and remember everything is an object, they all exist in the LDAP quote-unquote database. So LDAP is kind of like your source of truth for all this information in an Active Directory domain. And every domain controller is also an LDAP server listening on 3 different ports. You got traditional LDAP, LDAP-S for secure, and then the LDAP global catalog. And the nice thing with LDAP is there's really no special privileges needed to bind to the LDAP server and perform some queries. So if you just have the most unprivileged user, but as long as it's a valid user account, you can perform almost all the LDAP queries you'll want to map out the domain. If you're not familiar with LDAP, I've never really used it before, the syntax can be a little alarming. It's based on x.500. I'm going to give a quick overview here. Essentially, every single object in LDAP has a distinguished name, which is a hierarchical path of where it's located inside the directory, but it's also its unique identifier. So in Active Directory, a user object, for example, Trevor Hoffman here, that's his complete DN. And you can read it from right to left hierarchically. The DC is the domain component, and in Active Directory, you can take the domain and you just split it up into the domain components. Then you have OUs, which you can think of as folders. They're organizational units. There's no rhyme or reason. It's however the administrator kind of wants to organize his domain. He creates these folders called OU. And then a common name, which is the friendly name you'll often just see it referred to as. And every single DN has lots of attributes. Here's what that looks like in Active Directory. This is the LDAP entry for that Trevor Hoffman user, and these are all the attributes that are stored for that user that we're able to query for with just a standard domain user. And it contains all his personal information, his first name, last name, address or phone number, email address, but it also includes things like all the groups he's a part of, some timestamps when the last time he logged in or changed his password is. His GUID and his SID are also stored as LDAP attributes. And then down here on the bottom, his SAM account name and his user principal name, which is what he'll use to log in to the domain, is also always stored in LDAP. So you can use any LDAP client, but the client I find myself going back to because it's installed by default on a lot of Linux distros is Idapsearch. And Idapsearch kind of has a weird syntax also. So I just put an example slide up here. If you have Idapsearch and want to run an LDAP query, you basically just point it to the domain controller. You give it the authentication material, like a username and a password. And it's nice in Active Directory, you can use a UPN or user principal name as the bind account instead of having to type out the full DN. And then you give it the search filter and the attributes that you want. So a couple, if you want to just start doing some initial mapping, really broad filters to see the information that comes back. And one filter I like to use is just object class. So object class equals user is going to dump every single LDAP object that's a user object. And some of the more interesting attributes that are stored in LDAP for user objects, like I talked about already, are the groups they're members of, the last time they've logged in or the last time they've failed an account, the number of times they failed to log in, the last time they set their password. This is information you can just pull from LDAP attributes. And this little one-liner here will actually convert those ugly decimal timestamps to human readable date. Object class equals group will show every single group within LDAP. And some of the more interesting attributes, there's just common name, which is what you'll see the group referred to as. The members, so the objects that make up that group or a part of that group. And then member of, because you have to remember groups can also be members of other groups. So you have nested groups, and if a group is a member of another group, there'll be a member of attribute as well, and you can see if that group's part of a different group. Computers are great. Object class equals computer. Every single computer that's joined to the Active Directory domain gets an LDAP entry. And those LDAP attributes store metadata information about the computer that's useful for us if we're just performing reconnaissance. So some of the more interesting information just for every single computer object is we have its NetBIOS name and its fully qualified domain name. But we also have the exact operating system version that's running on that machine, the last time someone logged onto it, and through services and what function might that machine serve. And what's nice is you can combine the DNS host name that you get from LDAP with forward DNS lookups and get IP addresses, aka like a target list for your pen test, without actually having to scan the network because the domain controller will just give that all to you. Now, like I said, Microsoft took LDAP and added a bunch of cool things to it. And one of the coolest things that they added were these extensions through object identifiers or OIDs. And these let you craft really, really powerful LDAP searches. And you can do sort of advanced searching and filtering as you're doing LDAP lookups. And one of them called LDAP matching rule and chain is super useful because it allows you to do recursive lookups. And so if you chain that with the member of property, it will recursively go into every group and find transitive members of that group as well. So if you just drop that ugly kind of decimal OID into your LDAP filter, the server will recurse into all the members of a group, and if that's a group itself, all the members of that group, et cetera, all the way down the chain. So why is that important? Well, netgroup domain admin / domain is probably the first Windows command I memorized when I started out pen testing. I thought that was the most important thing if I ever got in a Windows machine. But if you run that on a Windows machine in this domain, you might think there's only 2 domain admins, administrator and A green. And that's looking it up over RPC and SAMR. But if we run that nested group query in LDAP for the domain admins group, we'll actually get a more authoritative answer, and it shows that there's 13 user objects that have transitive domain admin properties. So you should always trust LDAP and not necessarily the net commands if you're performing reconnaissance. Another useful LDAP filter is admin count. And this is just basically a Boolean. It's either 1 or it doesn't exist. And according to Microsoft's documentation, admin count attribute indicates that this object has had its ACLs changed because it's either directly or transitively part of an administrative group. So as a pen tester or someone who wants to just perform reconnaissance, like this is extremely useful to me because this makes my LDAP search like the easiest thing in the world. You can filter on this attribute. So if you only remember one LDAP search filter, like leaving this talk, just land somewhere and just remember admin count equals 1. And if you search for any object that has admin count equals 1, you will find every single object that's considered important enough to have its ACLs protected, and those would be like your high-value targets to go after, essentially all the domain admins or the objects that have essentially transitive domain admin rights. A couple other examples of some other OIDs that can be useful when you're doing LDAP lookups. There's OIDs for user account control, which can find user objects that have service principal names. There's OIDs that can help you find users and computers with unconstrained delegation. So these LDAP queries you can use to find all the servers that allow unconstrained delegation. Computers with protocol transition, so Kerberos to NTLM. And then everything's an object, like I said, so even group policy you can query through LDAP. If you just want to look for object class equals group policy, you can find all the information for every policy that's in that domain. Not necessarily that it's linked or enforced, but you can just enumerate that. But why do that manually? It's a pain to remember all that LDAP search syntax, and my cheat sheet kind of kept growing and growing and growing, and I finally said screw it. So I wrote a Python script to automate a lot of those common Active Directory enumeration lookups. It's called Idapsearch. You can find it on my GitHub. Over here is kind of a quick rundown of all the options. You can just pass it command line flags and enumerate some of that information. So just a quick demo video showing Idapsearch in action. I hope you guys can read that. I apologize. It's a video. I can't make it bigger. All it needs is a valid domain name. It'll find the LDAP servers over DNS like I talked about. And from an unauthenticated perspective, the dash functionality will just go ahead and find the LDAP server and tell us exactly what functionality level we're dealing with. But if we give it a username and a password, then we can actually perform more valuable information or more valuable queries. So -C, this is enumerating all the computers in the domain and explaining what operating system they're running, what patch level they're at. As an example, because this has been a hot topic this week, unconstrained computers will show me all the computers that allow unconstrained delegation. Domain control is expected, but definitely not a Windows 10 workstation, so that's something to target. User spins will, of course, show Kerberosable user objects, and I'll talk about that at the end. Admin objects does that admin count equals 1, so this is every object that has its ACLs protected. So it includes basically all the domain admins plus groups plus service accounts or anything. And just to show if we come across a group and we just want to see who's a part of like IT admins, that's really easy to search in LDAP, and we can just quickly pull out all the group members of that account, or sorry, all the group members of that group. And then the last thing, LDAP supports fuzzy searching. So if I wanted to just find someone named John in the domain, I can just look up John. It'll show me all the possible matches. I choose the one that I want, and then it goes and it pulls out all the actual information for that user. So just a useful wrapper if you're ready to run LDAP queries or you find yourself kind of wanting to find that information quickly and don't, like I said, have access to PowerShell or just prefer Python, Idapsearch is a great tool. So kind of in summary for LDAP, LDAP, like I said, consider it the source of truth for all objects in Active Directory domain. It's really the first stop that I would go to try to map out a domain. And the protocol is like fairly easy to work with when you get the hang of it. And there's lots of ways to query it. It is an open protocol, so find whatever client you want in any language you want to write a script in. Like there's going to be an LDAP compliant library for it, and then you just start putting those same LDAP filters in, and you can pull that information out. And as long as you have any valid domain account, you can run those LDAP queries from anywhere you have network access. So it's a great way if you just have like a username and a password that's super unprivileged but can't log in anywhere. You can just run LDAP queries against the domain controller and find some more valuable information. And I said potentially stealthier in question marks. I think a lot of security tools, or the last time I looked, were listening on the domain controller and flagging potentially sensitive MS-RPC calls, like looking up domain admins or protected objects, but they had a gap when it came to LDAP. I don't know if that's the case anymore, but I think that more people are kind of looking at NetFlow and RPC traffic than LDAP, so this might fly under the radar a little bit more if you're concerned about that. And I'm always adding to Idapsearch, so if there's more useful LDAP queries, and there's so many that are out there, including more OIDs, PRs are welcome, just shoot them my way and we can just keep the script alive. All right. Let's talk about the three-headed dog in the room. So who here feels like they are comfortable with Kerberos? Show of hands, okay? And how many of you are not liars? I'm just playing. Every time I think I'm comfortable with Kerberos, and every time I see a talk or look back into it, I realize I'm a noob again. Kerberos can seem crazy, crazy complicated, and so I'm going to try to level set and just explain enough of the high-level concepts so that we can get into some of the fun stuff without going into too many of the technical details that really hurt my brain. So it took me a long time to grok Kerberos. I didn't quite understand it, and it can seem really complicated and, like I said, easy to get lost in the technical details. But what helped me to kind of put it into perspective is it's just single sign-on. And it's essentially the OG single sign-on. So if any of you in your work use like single sign-on providers, like Okta or OneLogin or SailPoint or something like that. Kerberos is kind of like the precursor to that, and it's analogous to a single sign-on provider. And if anyone here is in web apps, like I came from that background, when I started thinking about it like SAML or OpenID, it made more sense. The idea is you authenticate once to a trusted source. It's the single sign-on portal. And then you don't have to provide your password to any other services in the domain. The single source delegates all your authentication. And the single source there is the Key Distribution Center, or the KDC. So in Windows, the domain controller is the KDC. And the KDC is made up of two parts, the authentication service and the ticket granting service. They're not super important to like keep in mind right now, but they just exist on the same domain controller. Now I'm going to try to walk through kind of a flow that made sense for me if we're talking about Kerberos here. The first step as a user, I start my day, I log into my machine. I'm going to go to my SSO portal and sign in with my password for the one time that day. And the SSO portal in this case is the domain controller, and it's Kerberos. So I send my password to the domain controller. The domain controller validates my password, and it gives me a session cookie. I mean, a ticket. But it's really, in my mind, like a long-lived session cookie. And it's called a TGT, or a ticket granting ticket. As long as I'm in possession of that ticket granting ticket and it hasn't expired, I never need to show my password again. That ticket granting ticket is all I need. Now a little bit later in the day, I want to log into a server called Servo1, and I want to just mount like an SMB share over Servo1. So I go to Servo1 and I say, hey, I want to mount your SMB share. And I need to authenticate myself. So Servo1, quote unquote, redirects me back to the domain controller. If you're kind of thinking about this in like a web app flow, I get redirected back to the domain controller. Now I show my TGT to the domain controller, which proves I've already logged in, I've authenticated myself, and I say to the domain controller, I need to access SMB on Servo1. And the domain controller goes, okay, here's another cookie, another session, or another ticket called a service ticket that you can present to Servo1 that will let you in. And it's only for SMB on Servo1. And that's called a TGS, or a service ticket. Now I get redirected, quote unquote, back to Servo1, and this time I present my service ticket. Servo1 trusts and can verify that that service ticket is legitimate, and that service ticket has all the information about me and my user and my group memberships. And Servo1 goes, okay, this is legitimate. Go ahead, we'll set up the SMB connection. Did that kind of make sense? At a super high level, that's kind of the Kerberos flow right there. And it's Kerberos in 4 bullet points, which might be a new record, I don't know. But I could talk about this and go into a lot more detail. But this is all we really need to know to understand some of the Kerberos attacks. Now, under the hood, Windows does so much to make this seem really seamless. Like, it should when it works. It really is like seamless single sign-on. So as a quick example, if we're on a Windows machine, WSO1 in this case, and we're going to try to mount the SMB share for WSO2, I can just do a dir command, and all of a sudden I'm browsing the SMB share. It seems like magic. But under the hood, all those steps and those 4 bullet points I just mentioned actually happened. And they're actually nicely color-coded here in Wireshark. So I'll walk through them real quick to kind of hopefully let it sink in. The first step is I did a DNS lookup. I need to find out where WSO2 is. So I do a DNS lookup and I identify where WSO2 is, and that's the blue. Then I go to WSO2 in yellow and I try to set up an SMB connection. And WSO2 responds to me and says, you need to authenticate yourself. Let's do the Kerberos dance. We'll use Kerberos for that. So then I get redirected to the domain controller, and that's purple. And now I'm talking to the domain controller over Kerberos. And I'll go to the authentication service, and that's the first 4 packets here. I'm talking to the authentication service, and I'm sending them my password. And in return, I'm getting the ticket granting ticket, a la my single sign-on session cookie. Then the last 2 here, I go back to the domain controller and I say, okay, I've got my single sign-on like TGT here. I need to access SMB on WSO2. And the domain controller goes, okay, here's a TGS that has all the information you need to do that. And then finally, I get redirected back to WSO2. I present my TGS, and this time the SMB session is successful, and we proceed to set up that entire session, and I start mounting it. So all those steps happen really quickly in succession underneath the hood, but they are happening every time. And if we do a K-list on Windows, you can see the tickets that are in your ticket cache. I suppose you could use Mimikatz too, but this is the preferred approach, I suppose. And we can see exactly the tickets that we would expect to see in that dance, that walkthrough. Ticket number 0 is the TGT. So we got that from the domain controller by giving the domain controller our password. Ticket number 1 is the specific service ticket to access SMB on WSO2. And that says it right here, CIFS, which is the SMB service, on WSO2 Win7. And that's what we use to actually set up the SMB session. Now, 2 things really important to remember when it comes to Kerberos. 1, service tickets are very specific services, not hosts. So they're only good for a specific service-host combination. I can't use that to access RDP on WSO2. I'd have to go through the whole process again. And this is the big one. Kerberos is an authentication protocol. It's not an authorization protocol. It was not designed to be that way. It only validates who you are, not whether or not you should have access to what you're requesting. So you will actually always get a service ticket from the domain controller if you want it. Even if you shouldn't be able to access that service, like you can usually just check it out. And it's up to the consumer, in this case Servo1, to make the decision to whether or not to let you in with that service ticket. How does it do that? Well, this was a Microsoft addition to Kerberos to kind of bolt on authorization. And they did it by attaching a privileged attribute certificate to every single ticket in Kerberos. And this is basically like an encrypted blob that contains, among other things, who you are and all the groups you belong to. So anytime you actually present your ticket, someone can decrypt the ticket and look up who you are and then make the decision to whether or not to let you in. And I think this is sort of the source of a lot of abuse when it comes to Kerberos, is that this pack was added to the tickets and authorization and authentication kind of got mixed up. And we'll talk a little bit about forging these by the end. Cool, so everything that I've done previously, the LDAP search commands, the WMI exec example, I haven't actually used Kerberos yet. All of that's been doing a different type of authentication called NTLM authentication, which is a challenge response, using an NT hash of the user's password. But that doesn't mean I can't. And this is where the fun stuff comes in, because Linux can totally speak Kerberos. There's plenty of Kerberos clients, and the Windows implementation of Kerberos is compliant. So I can use any Kerberos client on Linux to talk with the domain controller and do the Kerberos authentication dance. So to set that up, and this is something I love doing when I'm on a pen test or just have a Linux machine, is I will just install a Kerberos client and set up the configuration as follows. So a popular one is Heimdall. So on Linux, if Debian, for example, apt-get install Heimdall clients. The other information we need is the configuration information. And then we need DNS and we need time. This is what it looks like on Linux. To set up like a really simple Active Directory domain as a Kerberos realm, we have to modify etc/kerb5.conf. And we have to define the Kerberos realm. In Windows world, it's pretty much always the fully qualified domain name, just uppercased. And then we have to point it to where the KDC, the admin server, and that's it. And then where the default domain is. This is the minimum you need. And remember that none of this information is secret. Like, it has to be broadcast, it has to be advertised, and we can always look that up via DNS serve records to set up our client. Kerberos also so tightly is coupled with DNS that DNS has to work. The easiest way, if you're doing this, is to just point your local name server to the domain controller and let the domain controller handle all of DNS resolution if it's enabled to do that, or just point it to whatever name server is being in use in that domain. And then time also has to be in sync. And so the easiest way from Linux is to actually sync your local time with the domain controller's time, and you can do that with the rdate utility. So if you have all that information and you have it configured and you have it set up, you should be able to go ahead and run kinit, which is the utility to kick off and check out a TGT from the authentication service. It'll prompt you for a password, and if you do klist on Linux, it'll show you your current tickets. And so if it's all configured well, it should work, and it looks like this. We can enter T. Hoffman's password, and klist will show that we actually have created a ticket cache file. It's in the temp directory. Our principal is who we expect it to be, and we have a Kerb TGT that expires in, shoot, I forget what the default is. It's less than a day. When we have that, we're off to the races. So now any tool that supports Kerberos authentication can be used with that ticket cache file or that C cache file. And there's actually a lot that have it baked in if you just look in the man pages or the command line flags. If you see a reference on a particular tool to GSSAPI, That's pretty much Kerberos authentication. GSSAPI is the auth mechanism that Kerberos 5 uses. And so you can use GSSAPI, or if you see a reference to it in a man page, try using it with Kerberos. And most tools will require the well-known environment variable here, KRB5 CC name. So if that's not set, you have to export that to your actual Ccache file. So here's some quick examples, like the Samba utilities work great with Kerberos. If I have it configured and I've already gone and done a kinit and checked out a TGT, I can use SMB client with -- Kerberos and browse Windows shares using Kerberos authentication. RPC client as well totally easily supports Kerberos with -K. And notice in both these cases, I don't need to provide even a username because it's reading all that information from the Ccache file. And LDAP search. All those LDAP search fun queries we were doing, I was using NTLM Auth. I can do it in Kerberos too. As long as Kerberos is configured, --Y GSSAPI will tell LDAP search to do authentication over Kerberos instead of NTLM. And then I don't need to provide a username or a password. I can use tickets. And just a sanity check to make sure it's all working like we would expect it to, you can always go back and look at KList and see the service tickets that you've been checking out. So we can see in this case, we started with the TGT, and then I ran an LDAP search query. So as expected, I checked out a service ticket for LDAP on the domain controller. And then I did an SMB mount. And so as expected, I checked out a service ticket for CIFS on WSO1 Win7. So it keeps track of your service tickets in the same Ccache file. And all the Kerberos all the Impacket scripts also fully support Kerberos. So if you have a Ccache file already, you can give it -K -nopass. Or you can just do -K and give it a password, and the Impacket script will actually get a TGT for you. So these are just two quick examples. PSExec or WMI-exec, just using it with my existing Ccache file, I can execute code and do RPC calls and all that fun stuff over Kerberos from Linux. And that's useful because occasionally you might run into a situation where NTLM Auth is disabled. I've never, I think, heard or seen of an organization that's fully been able to get rid of NTLM. But if there's a servers or like an OU that has NTLM Auth disabled, a lot of your traditional pen testing tools just fail to work. Metasploit, CrackMap exec, a lot of these tools are based on NTLM authentication, and you can't really do anything with them. But remember, if you have a password, you can always do Kerberos authentication. So as long as you have a password, you can just drop to Kerberos authentication and get around this. And that's what this looks like here. If you try, this is me trying to run WMI-exec against a machine, and I get a SMB session error, status not supported. That means NTLM Auth is disabled. But I know this user's password, so I just do one extra step. I check out a TGT for that user, and then I do WMI-exec with Kerberos authentication. No problems there. I land my shell. All right, kind of a brief detour now to another pen test technique. Sometimes if I'm on an internal network and I can't get a foothold, nothing's working, I have to resort to some password guessing. Because someone somewhere is always using password 123 or company 123. So brute forcing passwords in Active Directory is generally pretty tough. Most domains have a lockout policy. It's pretty noisy. There's lots of security events. And in my opinion, it's also pretty slow. For example, like SMB sets up an entire connection and tears it down every time you try to test a password. And as attackers, one technique we like to use a lot more than password brute forcing is password spraying, right? Which is where you just do a horizontal spray of a single or one or two common passwords against a big list of users. Like I said, it's noisy. All of this traffic here in Wireshark is the test one password if I tried to do it over SMB. So there's lots of TCP traffic that's generated, and there's tons of logs. Anyone should probably be familiar, right, with the big event ID 4625, which is an account failed to log on. So if you start seeing your SIM blow up with tons of these event IDs, someone's doing something pretty bad. So I started thinking about, like, what other ways can I do password guessing on an internal Windows domain network? LDAP binds was interesting. It was actually quite a bit faster, but it still generated a bunch of 4625 events. But I had the question, well, what happens when I do this? When I do a kinit with a Kerberos client and I type in a bad password and it fails and says password incorrect? this is what happens. 2 UDP frames. I literally send 1 UDP frame to the domain controller with my password, essentially. It's an encrypted nonce. And the domain controller responds with like a success or a failure. So only 2 UDP frames to check a password is pretty efficient and pretty quick. So I started thinking about this and decided I wanted to try to write the fastest brute forcer I could. So I'm happy to announce and release, I just made the GitHub public, a new tool that I wrote called Kerberos. And Kerberos is my first Go project. It's written entirely in Golang, which has the advantage of being completely cross-platform and cross-architecture. So anywhere you land, you can compile this binary and run it, even if you're on like a PowerPC or something like that. It's multi-threaded and takes advantage of Go's concurrency. So combined with small UDP frames, this thing is insanely fast. It can auto look up all the KDC information via DNS, and it has 3 main functionalities for now. We can enumerate valid accounts just by guessing usernames. We can do a password spray against a list of usernames, or we can brute force a single user with a huge list of passwords. And my binaries, I'm compiling binaries for common platform and architecture, Windows, Linux, and Mac. And you can always download the latest binaries directly from GitHub releases. So demo gods hopefully are working, and I'm going to try to demo Kerberos real quick. Can you guys read this? Okay. So I'm on a Linux machine here, and I have the Kerberos binary. It's Kerberos Linux AMD 64. There's a couple things I want to try. First, let's say I have a list of possible usernames that I've consolidated from LinkedIn or dumps or something like that. I've got like 10,000 of them. If I run Kerberos and do user enum, I just give it the domain, and then I give it this big list of possible names. And this is going to do some Kerberos pre-authentication and see if these usernames exist, judging by the error messages that come back from the KDC. So it found the KDC, and it starts enumerating some valid usernames for me, and it's done. And I got 40 valid usernames, and I tested 10,197 usernames, and it got cut off there, but 5.4 seconds. So pretty quick. Next, let's say I have a list of valid domain users, and I've dumped this maybe from LDAP, and I have 2,700 or 2,755 domain users. And I want to see, are any of them using password 123? So I can use Kerberos, and I will do a password spray. I have to give it the domain again. And then I give it the list of domain users I want and the password I'd like to try. So we'll try password 123, do a clean sweep against every single domain user. Found the KDC. There's 1. There's 2. And I tested all 2,700 domain users in 8.2 seconds. So really quickly enumerated right there 2 valid accounts that I have just through some password spraying. And then the last function that I'll demo is if you're sure that there's no lockout policy in place and you want to just take one user and just blast a bunch of passwords against them, we'll take the top 1,000 most common passwords, and we'll do a brute user attack in lab.ropnop.com. We'll give it passwords.list, and then the user that we want to brute force against, in this case, it'll be Trevor Hoffman. So this time, it's just targeting one user and blasting it, and I got the valid login, and I tested 1,000 possible passwords in 2.9 seconds. So it's pretty cool. It's really quick. It was sort of a challenge to myself to learn Go. Multi-concurrency is awesome. UDP is fast, and Kerberos is pretty fun. Oh, that was my backup video, but thankfully it worked. Oh, and for anyone who might want to give me crap for not writing PowerShell tools, I just wanted to show the exe works fine in PowerShell. So what about logs? I actually had a major WTF moment like a year or 2 ago when I was playing around with this because I was blasting like so much Kerberos failed traffic all over the place. I went to my domain controller, queried the security log, and I didn't see a single failure. And I thought that was a little bit odd. Granted, I'm not like a blue team or an Active Directory security like guru. But I investigated a little bit, and I think this is really important. Turns out that everything I'm doing is doing Kerberos pre-authentication, and failing Kerberos pre-authentication does not trigger the traditional 4625 account failed to log on. Because we never actually logged on to anything, we just did a little pre-authentication dance and got a ticket. So you actually have to enable Kerberos auditing, which is in a different area than your normal like log on or log off events. So you have to make sure if you are running a domain that you have that enabled. It's considered best practice, but this is really stressing the point that like you should be enabling Kerberos auditing, and not just enabling it, but alerting on it. Because then we start seeing all this stuff. And the two main events that are generated through that type of technique is event 4771, which is a Kerberos pre-authentication failure, and event 4768, which is a TGT was requested. And when we do the user enum, that's the only one we're doing. So user enum doesn't actually count towards a failed lockout at all because we never even tried a password. We were just gauging whether or not the username existed. So kind of in summary there, I believe that Kerberos pre-authentication is much faster than any other like password spraying or brute forcing attempt, live brute forcing attempt that's out there. And I think it's potentially stealthier. Anecdotally, I don't have enough like evidence to go on here, but just giving this talk internally and talking to a few people, I know that there's organizations out there that like this is a visibility gap for them. They're not necessarily looking at or alerting on Kerberos pre-authentication failures, and they really, really need to be. All right, okay, I'm doing okay on time. So we'll go into some more Kerberos fun here. Specifically, how to do some privilege escalation and working with hashes. All right, so let's talk about spins. Spins are service principal names. And in Kerberos, you can always request a service ticket for a spin. I mean, that's exactly what they're designed for. If you have a spin, it means that you want to accept Kerberos authentication, and I can therefore check out a service ticket for that spin. For example, if I want to access RDP, I will go to the KDC and I will request a service ticket for the spin associated with RDP on the server that I want to access. Now that service ticket is encrypted with the spin owner's, NTLM password hash, which means that it's actually possible to crack service tickets offline. You can just brute force them until you find the decryption key. Generally speaking though, that's useless because for most machines who are the spin owners, it's encrypted with their machine service account, which is a super long randomly generated password. But sometimes spins can be tied to user accounts, and when that's the case, it's encrypted with the user's password. And as we know, users are terrible at picking passwords. So this technique is called Kerberosting, and it was initially presented at DerbyCon. I was in the audience there, and I had no idea what was going on, but I think I finally get it 5 years later, or 4 years later. So Kerberosting, three-step process. It requires a valid domain account. So you need to have at least one valid domain account. And then you find spins that are tied to user accounts, which is an LDAP filter that I shared already. You request the service ticket for the spin, and then you brute force it offline, and if you can successfully decrypt it, you have found that user's password. And Impacket makes it so easy with their Python script get user spins, which is one of the ones that I compiled to a static binary. So this works fine if you download it. You can run get user spins dash request the domain and the one valid user that we have. And it will do an LDAP lookup, it will request a service ticket, it will spit out the hash, and that hash is like in a crack-ready format. So you can feed that hash right into hashcat, mode 13,100, and just start an offline brute force attack. And if we crack it, like we did here, that what we've cracked is the password associated with the user account who had the spin. And the user account we can see here is vulnscanner, and he's a member of IT admins, which means transitively he has domain admin. So it's a way you can get domain admin. It's a way I've gotten domain admin several times. So passwords are great, and they're usually pretty easy to find in clear text, but sometimes you can't get a clear text password and all you have is a hash. For NTLM Auth, pass the hash is still around. Pass the hash still works great. But how can you do Kerberos authentication without a password, since I thought Kerberos was based on passwords? Well, it turns out you can, because the AS request to get a TGT doesn't actually use the password directly. It derives an encryption key from the password and uses that encryption key. And the NT hash is an encryption key. So if you have the NT hash of the password, you have everything you need to actually check out a TGT. And this technique is called overpassing the hash. or pass the ticket, I've also heard it referred to. And I'll show two ways you can do this. One is with native Kerberos clients like Heimdall, and then of course one is with Impacket, because you can do everything with Impacket. So our scenario here is, let's say we have the NT hash for a user named Tony Gwynn. If we want to do it natively with Heimdall Kerberos, passing the hash actually documented this several years ago, and it's been in my bookmarks since then. But you can use the key tab utility and create a key tab file, which is a Kerberos construct that just stores encryption keys. And you specify that the NT hash is the encryption key you'd like to use. And you have to specify that the NT hash is ARC4 encryption, HMAC with MD5. So when you do that, you can then use kinit and provide it the encryption key directly from the key tab file instead of a password. And you will check out a TGT for Tony Gwynn, even though we don't know Tony Gwynn's password and just have the hash. Of course, getTGT also does this for you. We can just request the NT hashes, and getTGT will create a Ccache file. The Ccache file can be used with Heimdall Kerberos, and we can see the same result. Now, NT hashes with ARC4 encryption could actually flag some Windows alerts, so I caution you, because it's not the best or default encryption anymore in Active Directory. Modern AD is using AES-256 encryption for Kerberos authentication or AS requests. So every user also has AES keys that are derived from their password. And those AES keys can be somewhat harder to come by, but they're still there if you look in Mimikatz or Secrets Dump. And here's AES keys for a user named Will Myers. The exact same techniques work. Use KTUtil, just change the encryption mechanism to AES-256 and paste in the encryption key you got, and you can get a TGT. Same with getTGT with Impacket. You just specify AES key, and you get a Ccache file which contains your TGT. Okay, cool. I've got a couple more minutes. So the last thing I wanted to touch on, and I could really go on this kind of fun stuff forever, but I think these kind of built in nicely, is abusing Kerberos for persistence, specifically golden and silver tickets. So I think you probably heard of golden tickets, silver tickets. They're very well documented. I don't want to spend too much time on them, but I feel like they fit in nicely here because I want to focus a little bit more on their practical usage. And a lot of the documentation and like tutorials that were out there that I found were using golden and silver tickets like with Mimikatz or Kekio inside Windows, and I wasn't quite sure what to do with them if I was on Linux. So with Mimikatz or Impacket, you can forge your own TGTs or forge your own service tickets. And if you are forging your own TGT, that's a golden ticket. If you are forging your own service ticket, that's a silver ticket. To forge a golden ticket, we need the master encryption key that's used by the domain controller to encrypt all the Kerberos responses. And that's an account called KRB-TGT. For the silver ticket, we don't need that. But we do need the encryption key for the machine that we're trying to access, so the spin owner. They have their own password hash or encryption key. So practically, it looks like this. Ticketer.py is the Impacket script that you can run anywhere as the binary or as the Python script. You provide it the key, you give it the domain SID, you give it the domain, the default duration, any additional groups that you want it to be a part of, and a username. Because this isn't just forging the TGT, it's also forging the pack. And I talked about how the pack is embedded inside the ticket. This is actually going to create the entirely forged pack, so we can put in any user or group information we want as well. So I hope you can read this, but this is using the ticketer binary. And I've put in the AES key of the KRB-TGT account that I got from the domain controller. The domain SID, the domain, I'm just making it good for 1 day. And the username I completely made up. And I just made up a user called Hello Troopers. And Ticketer creates a Ccache file from scratch. And it's a valid Ccache file that can be used with any Kerberos client. So by exporting it and using it with KList, we can see the information in here. And we actually have our principal called Hello Troopers, which is a made up user. But we have a valid TGT that hasn't expired yet for the domain. And then we're off to the races and can use that with any valid Kerberos tool. So I just wanted to show you can use it like with Samba, for example, SMB client-K with Hello Troopers. I've mounted the CShare directory on the domain controller, and I'm a user called Hello Troopers that don't even exist. That's the power of golden tickets. It's really been demoed before, but that's how you would do it from Linux. And silver tickets are slightly different. They are useful for persistence to a single host service combination. So you have to recall service tickets are only good for service host combos. And I think they're stealthier than golden tickets. The reason being, you'd never actually talk to the domain controller. With a forged silver ticket, you can go directly to the service you want to access and they will let you in. So you don't have to go back to the domain controller and check out a ticket. You have to specify the service you need. And if you're trying to get code execution at a later date, you're probably going to want CIFS and or host. So very, very similar looking command with ticketer. But in this case, our AES key is not KERB-TGT. The AES key is the machine account password or the machine account encryption key. And we also give it -spin for the spins we want to embed or the spins that we want to forge the ticket for. And so in this case, I'm requesting it for CIFS, which is SMB, on WSO3 Win10. And again, a made-up username called Silver Troopers to show that it doesn't matter. The Ccache file is valid. If we feed it to Heimdall, we'll see something kind of unusual that you normally probably wouldn't see, is your Ccache file contains a TGS, but not a TGT. So we have the principle here. We have a ticket for CIFS. We don't have a TGT. We never needed it. We didn't request one. And with SMB client, it works fine. With -K, as long as we're accessing WSO3 Win10 and we're using it with Kerberos authentication, doesn't matter that our username is made up, it will let us in and we can mount it and use that Ccache file with any Kerberos client. So I think that's my stopping point. Like I said, there's a lot more fun things that could be done, but this was kind of intended to just be the foundational knowledge, and I encourage you to go out there and just experiment and play more with this type of cool things you can do with these open protocols. Kind of in summary, there's so much attack surface in Active Directory environments. I think I saw in the last presentation, Biggie Smalls once said that the more complex a system is, the more attack surface it has. There's always things that you could be looking at. Even if you were just getting started in Active Directory security, go poking around, reading MSDN docs. You'll probably find something that no one's really looked at before. You don't need Windows to talk Windows. If you do not like PowerShell, don't worry. You can still be a Windows pen tester. That was the conflict I had a couple years ago, and then I found Impacket, and it's just been great. So DNS, LDAP, Kerberos, MS-RPC, you can just use other tools to talk to those protocols, and you can still be an effective Windows pen tester or security researcher with no .NET or C# or PowerShell if you'd like. And then more tools and techniques will make you a better pen tester. So go exploring. Some amazing research is being done, like even just this week at this track. There's such cool stuff coming out about Kerberos. I really think there's like more to be found there, and Kerberos is not as scary or as intimidating as it might seem, because I was there once and I really, really enjoy it now, and there's still things that I love learning. And Impacket is awesome. And then a quick shout out, no, this is not the AD security track speakers. This was a slide that I created beforehand. But these just big shout outs to guys that I've learned a ton from, and countless more, because I'm sure I'm forgetting people. And these are the slides. The 3 tools that are mentioned are on GitHub. Like I said, I gave this as a workshop. It was a almost 3-hour-long workshop at ThoughtCon last year. My slides are posted for that, so if you enjoyed this, I would encourage you to check that out. There's more information deep diving into like MS-RPC, for example. But cool, I think I've got time for a couple questions.
Thank you very much, Ronnie. Any questions?
Thank you for the talk. You mentioned the Idapsearch for the enumeration process. Did you ever discover a client that uses search flags as a part of a mitigation so that you cannot query that much from the AD?
Great question. No, but my sample size is small. So I've actually been deferring a lot to some of like the more prolific red teamers that are here who work with larger organizations to see if those mitigations are in place. I haven't personally encountered it, but that doesn't mean that no one is out there using it. But it's a great mitigation for sure.
Thanks again.